Hello, hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. Yes, coming back to this setup again, let us remind ourselves. Ball X is thrown vertically upwards from height h with an initial speed of 22 meters per second. At the same instant, a second ball Y is dropped from the same height as shown below in the diagram. So as ball X is projected upwards, ball Y is dropped. Okay. Ball X takes 12 seconds to reach the ground from the point of projection. Calculate the time taken by ball Y to reach the ground. So when you look at this scenario, what do we notice? Let us look at the one time taken for ball Y to reach the ground. Okay, let us just look about something here. Ball Y. What do we know about ball Y? We know initial velocity, which is 0 meters per second. What else do we know about ball Y? Nothing. So they want us to calculate time taken to reach the ground. And we know G is going downwards, so it's going to be 9.8 meters per second squared. So what is missing from this data which can give us the time? What is missing is the displacement covered or the height h. We don't have it. So if we don't have it, how can we get it? That time can be obtained from ball X. So what are you going to do? This one is going to be suspended a bit, and we endeavor on determining the height covered by ball Y, that height which you can get from ball X. So we are determining height h, and which is the same as displacement. Actually, displacement covered by the two balls. Because even ball Y covers that displacement. Let us look at ball Y. It moved upwards and then downwards. Now this displacement covered from point of projection to maximum height and then coming back to point of projection has displacement 0. Why? Because the ball covered positive displacement up and it covered equal downward displacement, both displacement being in opposite direction. So when you add them up, they'll give you 0. So the displacement covered by our ball X in this part is 0. So what is the total displacement covered ball X? It is height. And let us go back. What is the total displacement covered by ball Y? It is also height. So determining height is very fundamental here. Height happens to be the displacement covered by ball X, and also is the same displacement covered by ball Y. And height can be obtained from ball X through what? Let us look at what we know about ball X. We know VI, which is what? 22 meters per second. Okay, we know our G is going upwards, which is negative 9.8 meters per second squared. What else do we know about ball X? We know the time covered, time taken for entire trajectory. and that time is 12 seconds. Then you bring your unknown, which is going to be the displacement covered. This displacement being the same as height. So with this information, what do we know? We can come up with the formula. Let us look at the information. This one takes us to the third equation. What does it say? Delta x is equal to VI delta t plus a half a delta t squared. What are you calculating? We are calculating delta x. So what do we know? We know VI, which is 22, times the time, which is 12, plus a half times negative 9.8 times 12 squared. What you get out of that is going to be the displacement. So after substitution, we get our displacement as negative 441.6 meters. Now, what does the negative imply? Negative implies that the distance we have covered is below point of projection. You have to remember that from point of projection, if you take upward positive, the displacement covered upwards is going to be positive, and the displacement below point of projection is going to be negative. So this is negative because this is our point of projection, and the distance we are talking about, the displacement we are talking about, is below point of projection. Okay, now we have obtained it. What do? We go and use it with ball Y. So let us now come back to our ball Y and list everything we know. What do we know about ball Y? We know our initial velocity, which is 0 meters per second because it was dropped. Okay, what else do we know? We know our G, it's going downwards, so it's going to be 9.8 meters per second squared. What else do we know? We know displacement covered, which is going to be 441.6 meters. Okay, when you look at this scenario, why do we say it's positive? Because for the ball Y, that displacement is positive. Ball Y is initially going downwards. So the displacement covered by ball Y as it goes downwards is going to be positive because we took downward as positive for ball Y. Okay, what is missing here? The time. So what equation do we get out of this one? Let us see. It's the same equation. What does it say? Delta x is equal to VI delta t plus a half a delta t squared, and it's going to be 441.6. This one is 0 times time, which we are looking for, plus a half. That's going to be it's going to be 4.9 delta t squared, and the only unknown here is delta t. So what are we going to get here? Delta t squared is going to be equal to that divided by 4.9, and delta t is going to be the square root of that. And what do we get? Let's see what we get. So after substitution, we get our time as 9.49 seconds. So that is that. So we are going to cut this video here. We thank you for your time. We don't take it for granted. Don't forget the channel is PSSB, Physical Sciences Silver Bullet. See you next time. Bye-bye.